Okay.
Hello. Hello, can you hear me? Is that fine? Is that working? Is that thing on? Yeah, hello. This is, let me see if that works. This is me. And wow, I have a problem. I can't see my speaker notes. Well, I'm a core developer of XDB since 5 years. My name is Juri Leino. I also go by this weird little thing there. It's a play on my last name, -O. And I have been consulting for Exist Solutions and Gintech for the last 7 years. I mean, Gintech is a newer company, so since its inception. And in that time, we have done a lot for one specific website, history.state.gov. And as if you are as me and you are soaking information up like a sponge, you do look at the data you're handling and then think, what do they have on UFOs, right? And I looked it up. So I took my phone and put it in UFO, and to my surprise, I found an article about the Premier Minister of Grenada that visited in 1977 and spoke to then President Jimmy Carter and said something along the lines that, yeah, there was sightings of UFOs in Grenada and we should maybe look into that. Grenada, by the way, was, I fell deep into that rabbit hole. Grenada was then just 3 years independent, so this prime minister must have been the first prime minister of independent Grenada ever. And for some reason, they published that. If you don't believe me, this is a QR code to get to that article. So it is there. And there's more, by the way, if you search for UFOs on history.state.gov. And I noticed that because I saw search terms in the log files that scraped the database about UFOs. So, but how did the data get there? Obviously, it's the meticulous work of all the historians working at the State Department and sifting through the tons of data, historical and new stuff. And but also, it is in parts us. I'm standing here for a large group of people. Yeah, I'm not doing this alone at all. Even Alexandra did contribute to that, and I think a lot more people. I cannot mention them all. But what is being built is a publishing environment around XDB or with XDB. And yeah, I would like to read my notes. Maybe if I highlight them, yeah, it's better, at least. So as I said, Exist Solutions has supported the department since years. And what we especially like in the collaboration is that the State Department has a very strong stance on public data and open source. And so this is what we and the State Department stands for. I hope, at least, that I'm not saying something too wrong here. So, my request from my phone got somewhere. How did it get there, right? And the clouds opened, and there was this database. HSG Shell, which is also open source, and you can run it on locally. So there's a possibility to run the entire website locally. Does depend, this is where the request comes first at. It does depend on XDB, obviously. So it runs on that platform. But it also depends on two main libraries, HTML templating and tei-publisher lib. Tei-publisher lib is part of the tei-publisher the project started by e-ediciones, but it actually here predates even the naming of that project. So history.state.gov has used something even before it was named tei-publisher lib, but they still continue to use it, and both of these libraries that I just named render data. So we also need data packages. This is what the front-end service consists of, basically. I'm just picking out the important parts for today, right? All of these, the application and the libraries and the data, are all XAR packages. Who is familiar with XAR packages here? So there's obvious, yeah, even more. So that's, okay. XAR packages are a standard, and it's not only supported by XDB, but also by BaseX, for instance. And it's the standard way to deploy software to an XMLDB. We make heavy use of it. Where do they come from? Where do those come from? From GitHub releases. So everything that we do, all of these packages are built on GitHub, and each build will create a XAR package as a result. These XAR packages then are used in a Docker container that contains all of the project, which we use for two things. We use them in the GitHub releases to test before we release, and we provide that Docker container to local development, which tremendously sped up the setup of those projects. It could be a day before, and now it's just like half an hour. Ed Porter was so nice to introduce you to the benefits of Docker, and I'm very glad that you did that. We love Docker for exactly that purpose, although we don't run the CI in Docker, but inside of GitHub natively, and we don't use an enterprise license. But if you want to look into the entire setup, as I said, it's open source. You can look it up and you can copy it to your needs. So we even went further, and those GitHub releases are being built whenever a commit goes into the main branch. And that is even raising the version number to the correct version number based on the commits, and that is done by semantic release. And we are using conventional commits, which you definitely should look up. It's a great tool to specify the format you want your commit messages to be written in. And it's very customizable. There's another tool in a separate system that is the annotator, which will then, in the end, provide new data that goes into some of the packages. That we are not there yet, but it's this is already in productive use, and that annotator is also part of the tei-publisher family, and allows you to add persons and names, to tag persons and names and terms in a corpus of text. And it uses Spacy for that. So we send structured data to we transform structured data to text, send that to a model. It's here Spacy. This will likely change, and it's also written in a way that you have adapters for several different things, and that will then allow editors to, it will mark stuff in your corpus as potential names or potential places, mark those up, and then you can select with a custom authority. You can then, here they use custom authority that comes from Airtable. This is why it says Airtable. you can then say, okay, this is President Nixon that is talked about here, right? This name is President Nixon. And I can also show you, I think, there should be a slide below that, but there aren't. Okay, I will show that in the end. I have a slide where you can see how that looks like. The idea behind that is that it's a round trip. So when you have marked up 1,000 of those documents, then you can retrain your model to be better for the next 10,000. And as I said, Spatie is just one option you have. You can use any model that you want to train. Now I was only talking about how information got there, but actually, as I already said, we have several subsystems. There's actually a lot of servers. And now we need to get those servers somehow set up. They're all living in AWS for this project, definitely. We have also customers that run their own data centers, but here it's AWS. And to quickly set up new servers and also to be able to recover from this disasters quickly, we chose Ansible to set up new servers. Ansible is just one, you know, there's tons of out there. I'm quite convinced that you use your own setup, but Ansible works for our purposes very fine. There is, in the XSDB project, there's XSDB Ansible as a role to be used to set up Ansible endpoints or Ansible instances. Note that we don't use Docker here. We are setting up bare bones servers. It does work for our needs. It does work better for our needs here, and Docker only for testing and local development, because that way we have more control over really what is happening on the server. And one thing I forgot to talk about here in Ansible is that, where am I time-wise? Is that, okay. Updates should be idempotent. So when I run Ansible, set up a server X with a different role, set it up and run that same command again, it should do nothing. It should say everything is fine, right? So keep that in mind. This XSDB Ansible role sets up XSDB and configures it. So whenever a configuration change, I can run that same command again, and it will only change the configuration. And it also sets up packages and uses a new command line interface that was created, XST. What XST also does is allows us to automate installation processes of packages from several sources, like from the package registry that we have. There is a public repository in XSDB, but we can also run a private version of that. Depends on your use case. Here we have a separate one running inside of the AWS cloud of HSG. You can install local files. Sometimes you need to have this weird little library that only is used in your specific use case, and you don't have another place to get it from. So a local file system is an option, but you can also use GitHub releases, and this is obviously what we make big use of, because we have now this automated pipeline to get updates whenever there is a new commit. Now we have a server, and we now have them set up. There's everything running already, but data is updated, right? Now it's the use case of publishing that data. We have a staging environment, and we have a production environment, and they need to be even updated separately, obviously, because you first want to see what you is that okay what I want to publish before you put it into production? For that, we created Tuttle. Tuttle is a library that allows you to sync a collection with a Git repository. A collection inside of exist is then tied to that and knows which commit hash have I checked out, basically. So whenever data changes in that Git repository, we can run a command. And here is that slide I wanted to show. So I definitely want to show you the other one. Tuttle has sped up the publishing process by an order of magnitude, I would say. So there is specifically one package that's called FRUS, Foreign Relations of the United States of America. And FRUS is like 4 gigabytes of XML data, and publishing that every time when there was a typo fix is like crazy. So what we now do is we look at the remote hash and look at the local hash and then look at the diff, look at all the Git commits that were done, and then figure out what we really need to update. So that went down, even if you're updating several files, it's like minute or under a minute. So before it was 20 minutes, right? So there's a big difference because indexing is currently one big bottleneck in XDB that I have to admit. I can't like put it under the rug. So indexing is indexing as less files as possible is key here. This is the Tuttle API that is called. It's written in OpenAPI. It's an OpenAPI definition and uses the roster library that was also published a while ago under the e-editiones umbrella. And yeah, it has several routes, and one is git incremental for a collection, and then it will do that. I'm not going to show that today. If anybody of you want to see any of those libraries specifically, please come to me. I don't have enough time to show them all. It's just impossible. I'm sorry. So if you have interesting data, as the Department of History has, then people come a lot. And now we're faced with the problem, okay, it was not just people, it was robots, and even more. And they're constantly hammering your server. So we needed to come to a solution how to efficiently serve that website. Any XDB instance I have seen in production runs behind a proxy. So we have Nginx here, and Nginx has a caching option. So we have the Nginx cache. That's the easy part, right? You just serve every page that was served, you put into the cache, but you will hit limits. And especially we'll have some routes that shouldn't be cached, right? Searches shouldn't be cached, at least not for long. And the State Department even said, no, we want every content page to be, if it changes, to be immediately changed. So we had to find a way to do that, and we found one. And that is that the application, HSG shell, has a cheap way of knowing, okay, has it been modified with the if modified since header. So that the not modified check becomes cheap. We can do that every time. And if 304 modified comes back from the app, we just serve the cached website. And that also allowed us to sleep well at night. So we, after introducing this caching strategy, all of a sudden, a lot of problems went away. And all those bots, they just hammer away, but we don't have a problem. So we are almost at the end. What I just showed you is a bunch of things that you can pick and choose from to build a stable and scalable publishing environment around XDB. And I think the logo does show you this, this approach very well. Thank you for your time.
Thank you very much. We have plenty of time for questions.
Oh, was that fast? No. Exactly in time. At first. I have to admit.
Thank you very much. It's interesting to see what this Department of State historical is up to. It's always interesting. Mm-hmm. The concern that's floating through my head is not about any particular piece of this, but rather that, you know, the Department of State not only has an obligation to publish this stuff, but they have an obligation to be the keeper of records and make it publicly available here on out for all future generations, despite the fact that the leadership of the Department of State changes every 4 years, which might make it a little harder. I'm just wondering, there seem to be an awful lot of pieces here. Does that mean that there's more room for failure, and failure that you can't really control for very well? If one of these pieces doesn't survive an update to the operating system or something of the sort, are you in hot water?
Okay, at the heart of this is data that is encoded in TEI, as I said, tei-publisher, right? And this odd transformation that tei-publisher lib provides is something, so with your ODD file and a TEI file, you should be able to produce a useful output in 20, 30 years, because it's self-documenting. So not only the encoding is documented in that ODD file as well. So you can look at the TEI and have the specifics, but we even went so far as to move even more metadata into the TEI files, because that's the right place for them to live, instead of some weird place in a AWS bucket, where it was before, you know, and was scraped somewhere manually. So yeah, this is not the end of the road, don't get me wrong. There is much more, and we are continuously improving on that project, and we hope that we can do that in the future, right? If they choose to still work with us in the future. Yeah, I hope that answers your question.
Thank you.
Any other question?
So you mentioned that you use Docker in your testing. Can you speak to why Ansible was a better choice than using AWS and deploying Docker through K8s? You mentioned that it's more configurable, but in my experience, you can set up how much resources you request and all that good jazz with K8s and customize and whatnot.
Yeah. So the short answer is we had to go live. And a lot of that work was already done. And so we could build upon that and could actually have an improvement right now. The long answer is that Kubernetes is a whole set of new beasts that would require more resources to just do that. I hope, yeah, but we can continue that discussion. I'm not so familiar, I'm myself not so familiar with Kubernetes, but my colleague who is has said, let's not do this. And then he has a good reason for that, yeah.
Okay. No more question? Thank you very much again.